Let us discuss one important application of op-amp, that is non-inverting amplifier, and it will be also used as a voltage follower. So we are going to discuss these topics in this video here. So there will be a lot of questions that will be based on these two amplifiers. Let us see what is it. So non-inverting amplifier is an amplifier in which the input and output are going to have the same phase. So suppose there's an amplifier which is providing us some gain, that is A, and the input is applied as Vi, then the output voltage that we will get will be in the format of Vi into A. And in this case, the voltage, the output voltage and input voltage are going to be in phase. In phase means they are going to have either 0 degree or 360 degree phase shift. So suppose we have applied some sinusoidal signal to the input, and we will get some amplified version of the input signal that will be in the same phase, and there will not be any phase reversal in case of non-inverting amplifier. So let us evaluate the value of closed loop gain for the inverting amplifier. So here you can see we have applied the input voltage at the non-inverting terminal of the amplifier. So if we say this is node B and this is node A, then we can say the amplifier is going to have a virtual short, and due to virtual short, the potential at node B and node A are going to be same. Since node B is equals to Vi, so therefore node A it will also have the same voltage, that is Vi. This is all because of the concept of virtual short circuit. So at node A we are having the voltage that is equals to Vi. Now we can assume two currents that are flowing here, that is I1 and I2. And for discussing the amplifier, we will assume that the input bias current, that is IB2 and IB1s are 0. So we have to consider that IB1 and IB2 are, which is known as the biasing current, are going to be 0, and it is working in the linear region. It is working in the linear region. So therefore, we can apply the concept of virtual short. So these two assumptions are made by discussing the op-amp. So now let us write the equation at node A. So you can say at this point, if you apply KCL at node A, this will be I1 plus I2 is equals to 0. So I1 current is given by 0 minus VA upon R. This is 0 minus VA upon R. And I2 current is given by V0 minus VA upon RF. That is V0 minus VA upon RF, that is equals to 0. And we know the value of VA is equals to Vi in this case. So we can write that it is going to be minus of Vi upon R plus V0 minus Vi upon RF equals to 0. So from here we have to find out the value of V0. So V0 upon RF is going to be, it will become Vi upon R plus Vi upon RF. We can take the Vi as common, it will become 1 upon R plus 1 upon RF, that is equals to V0 upon RF. From here we will get a value of V0 as RF into RF plus R divided by R into RF. So this will become V0 equals to, this RF will get cancelled out, and this will become RF upon R plus R upon R. So we can write from here that it is going to be V0 is equal to 1 plus RF upon R, and that is the value of Vi is in the multiplication, right? So we can say this 1 plus RF upon R is nothing but the voltage gain. So for the non-inverting amplifier, the closed loop gain is going to be 1 plus RF upon R. And as you can see, it is having the positive sign because it is a non-inverting amplifier and output and inputs are going to be in phase with each other. They are going to have the same phase. So suppose we have applied some input signal that is sinusoidal, we will get the amplified version of the same signal, and there will not be any phase reversal in this case.